Hi everyone. My name's going to be on the slide in a minute, but I want to keep in mind for the next 45 or so minutes, deterministic modernization. That's what we're going to look at today. Not probabilistic, but deterministic. And that, I think, is especially important in an age where everyone is trying to move their tooling in a different direction. Every company is trying to sell you their own version of Son of Anton. And then, we find that there's maybe a better way to modernize instead. Now, by the end of this talk, I hope that you have a mental model of how to keep your code base in a clean, consistent state, even when agents do most of the writing of your code these days. So this is me. Some quick context. So I work at Moderne, which is the company behind OpenRewrite, which is an open source framework, which was started as Netflix about a decade ago. And we spend all of our times helping customers upgrade large code bases that they have. So these are banks, insurance companies, retailers. They have quite literally billions of lines of code. And we help them organize, strategize, and move that code along. So it's very much not a theoretical talk. This is actually what I do day to day. And presenting here is just a hobby that I have. Kind of odd. So OpenRewrite, for those unfamiliar, it's a framework for safe code modifications. And today we're going to look at how we use that now that we have these agentic tools to maybe run it or maybe expand it. And with that, we're going to look at the patterns that we've found to work well in these large organizations, and then help them tackle their own unique modernization challenges. And so I hope that you take away from these some tools and techniques that you can apply yourself when going back to work on your own challenges there. So there's a bit of a run through. This is what we're going to go through. First, we're going to look at the problem space. Like, what do we actually mean when we talk about modernization in 2026, when you have a lot of agents writing your code? And secondly, we're going to look at waves of change, a pattern that we have found to work well to decompose these large migration efforts into smaller, repeatable increments. Then we're going to look at using agents to write some of the automations that we're going to use throughout these patterns to not have the agent run loose and make changes on your code, but have the agent author something that can help you make the changes deterministically. And then we're going to look at the long closing tail to be able to drive home this change, because I think Sander said it nicely this morning. If a bus takes you 80, 90% of the way, that's great. If a boat takes you 80 to 90% of the way, that's not so great, maybe. So we're going to look at how to close that gap of where we can bring you deterministically and what to do for that last part of it. And then fifth, just the takeaways, like I said, the things that I hope you will think of in Monday. So then the problem space. So you might think that the goal would be to modernize your code, but very much it is not the goal for us. The goal for us is to have your code in a clean, consistent state and ready to deliver some future value that you want to actually be doing. We don't want to have modernization be something that you spend months or years on even. We just want to have you be able to bring your code to the point where you can reliably deliver the next bit that's actually going to help your company drive forward. So that also means that for us, I think clean and consistent is maybe better than partially upgraded. So if you do an upgrade and you introduce a new version of your framework, but you're not phasing out the older version, you're actually increasing complexity. You're adding a fifth framework, a fifth version that you need to keep in mind when switching between projects, that this one now each needs Java 25 and Spring Boot 4, whereas the other ones are still going back a decade or so. So really, we're going to look at how to get you to that state. And for that, we're going to do a very quick look back just through over the couple of years from, I think, what we've all experienced, where just before COVID, everyone was like handwriting code, just in the old days, which was somewhat nice, but I think that's something that we all kind of know and took for granted. And then gradually we saw some tools being added. So in 2022, everyone was looking for the off button on the inline suggestions that you got in your IDE that were trying to throw you off as you're trying to develop your code, and were really annoying, yelling at you, and you press a tab and suddenly you have 3 paragraphs of things you didn't want, you wanted a tab. So that's what we saw in 2022. But then gradually we got used to using these agents for initially some small tasks that you give it, go run off, do something for me, come back when you have it. And then, especially in our case, over the past 2 years or so, we've been using these agents heavily to give it a task and come back to me when you have it. And you'll have a couple different ones running in parallel. And we see the same patterns with our customers and users as well, where they will have multiple things running, depending on where you work. That might be years away, or it might be what you have already. You might be forced to work with one particular tool, or you can choose any of these tools already. But really, the shift that we're seeing now, 2026, is that you have not a user run the tools that we provide, but we have an agent being the first user of the tools that we have. So it's quite a bit of shift looking across just 5, 6 years to now have to optimize tools that we provide for an agent running these tools. Not a user, but an agent doing these things. And then zooming into agents. So we find that these agents, they are amazing at generating code that is plausible. Not necessarily correct, but plausible. So it looks correct. And if you then take that effect of producing something that looks correct, and you kind of scale that out, that is quite a bit of a nightmare that you end up with. Because while in isolation, each of these will look correct, it's very hard to then spot the error when the previous, let's say, 5, 10, 15, 50 cases looked okay. But then to spot the bugs, that's going to be a very challenging thing. So then, and what's the cause of that is that these agents, they pull things into their context, and they operate on that context. But what they pull in, that window of their understanding of your application, it's not always the same. They'll do some graphs, they'll do probabilistic graphs, they'll build up a understanding of your code, but it's not necessarily going to be reliable. It's not going to be deterministic, meaning that you end up with a slightly different migration if you run it once on your machine, once on your colleague's machine, once again tomorrow because you wanted to make a small adjustment, and that doesn't scale well. If you think of our customers, some of them quite literally have 300,000, 400,000 Git repositories. Not files, but Git repositories that they want to migrate, then you want to have something that is not going to make a series of guesses and hope that they all land correctly. So that is why we see that that non-determinism is something that is a tax that you pay as you work through this. So if you take the same input and you get a different output every time, that is going to be quite a challenge to work with. And then, of course, the business model of these tools is very different, very maybe opposite to what you want. What you want is to have your code upgraded, and what they want is to sell you a bunch of tokens. Which, if you think about it, their incentive is very different. They would rather have you update your code all the time, repeatedly, trying to get things right, whereas you really want to get back to work and deliver that next value for your customers. So this is why, we try not to use too much tokens as we do this work, find a way to work around that, and then, with that, hopefully get you on a path where you can consistently deliver these modernizations to get you in a clean, consistent state. So keep in mind that non-determinism is a risk, whereas if you take a deterministic program, that is something that you can test. It's also something that's very efficient, something you can repeat, and then with that, we hope to get you on a better path. So then let's look at how we plan these waves of modernization. So get the work that you want to achieve, be it a Java upgrade, Spring upgrade, different frameworks, libraries, whatever you want to do, and break it up into small things that you can actually run. So say that you want to be on the latest version of Java, Java 25, but you're coming from Java 8. I hope that you don't see that as a one-step migration. You don't go from Java 8 to Java 25 and hope it all just works. And if you work with, like some of our customers, large monolithic applications, mono repos, it's also not one pull request that you work on for a couple of months and then hope every day to resolve all the conflicts that you have to finally land that piece of work. So instead, what we're going to look is we're going to identify smaller increments that we can deliver as a sequence of migrations, each of them self-contained, each of one that you could potentially roll back, and that way decompose that large complex migration into something of a wave of a change. And suddenly you have something that is a plan and not a hopeful thing that you wish for. And all these waves, they kind of have the same shape to it. So you pick, let's say, a narrow transformation. Let's say that we want to replace every instance of Joe.time with the new Java time API, with new being just a decade old, which is nothing for a customer of ours. And then you codify that change as a deterministic recipe. So we have a way to have you define these types of migrations that you want to do, and then you dry run it. First on some unit tests where you know the cases, then you try it on a couple of small projects, and you preview the diff that might come out of it, and then that is before you even merge anything at all. And then once you build up confidence, you see it work well in some projects, that is when you start to ship the first initial projects, and then move on to the next wave. And like I said, every wave has that same shape to it, where you strive for that repeatability such that you can scale this type of work from something that you can run on an individual project to something that you can run on thousands of projects without getting thousands of folks involved. It's just you developing these recipes, focusing on a small bit that you get to know very well, and deliver that onto the breadth of the organization. So then, looking beyond that, it's not a hypothetical. So we actually do this with our customers. We actually have a workshop tomorrow, if you're interested to drop by, where we take you through a number of these steps in these migrations. Because while it's nice to have a wave identified, maybe you don't even know what you have just yet. We see that a lot with our customers, where different folks, different continents, you have no idea what the competitor that you bought 2 years ago was using. So you first have an assessment phase, where you try to figure out, what am I using? Where am I using it? Maybe why am I using it? Do I want to continue using it? And then from there, you start to plan those individual waves to allow you to tackle that migration. And then from there, we find it very useful to set a baseline first. So if we say that you have Java versions and your goal is to get you onto a newer version, then maybe you should just have everyone at the very least be using Java 8 in the feature set of Java 8. Such that when you go to the next increment, let's say 17 is typically a good one, you get everyone and everything up to 17 and not have that crooked, like I said, more complexity added by having a shift in different versions there. And then once you have that, you can also build out custom recipes the moment that you identify a blocker in part of that migration. So say that you want to go to Java 17 and you find that a certain library is not compatible, be it query DSL or something else, you can isolate that element, you can write recipes for that element, and try to then compose that into a larger recipe that will get you onto that version of 17. And this is then what every custom Spring Boot migration for all of our customers starts to look like, small increments that you deliver in this way. And just to show you that visually, you can see here on the right how I, even as a consultant, used to do these migrations at a customers of ours. So you take your one favorite service on the left, and every block here is a step in a migration that we need to do. And say you want to go from 8 to 25, then you run through those steps in sequence on one big PR. And like I said, you have to resolve all your conflicts across the times to take it to deliver that over the span of weeks or even months. That isn't great, because you only have value delivered the moment that you merge that one PR with all of that work. And even then, you've only fixed it on a single project. That is, in this case, when we have 25 projects and 5 steps for each of them, you're doing 4% of the work. Whereas what we propagate now is to identify those smaller increments and do those breadth-wise. So take a step, like if you want to go to a newer Java version, take first an upgrade to the latest Gradle version. Something you can automate, something you could deliver in isolation, and that by applying that broadly, you're reducing that spread of versions, a spread of build tools, and standardizing on that one step, deliver it, merge it, and be done with that step before moving on to the next one. And then gradually, you'll be able to deliver value in repeatable increments, each and every time just debugging one particular aspect of the migration. So I hope that you see how that type of approach will allow you to scale then in your upgrades. So then let's look at the next part, where say that the recipes that we provide don't yet help you get all of the way. So you need special customizations to allow you to do further upgrades. And this is where we find that agents are really helpful these days. Because what agents are good at is to produce new code. They're very eager to write code. They're not always helpful when you're trying to modernize something, but they are very eager to produce something in isolation that will help you maybe along that step. So if you then look at the steps that you need to complete a migration, writing a small recipe is something that an agent is typically very good at. We ourselves, we have 7,000 examples for these agents to learn from. We have extensive documentation. We have various ways that we expose, which I'll get to, how to write new recipes for these agents. And that then becomes a way for you to run that small migration that didn't exist yet as something that you can apply broadly at scale and know exactly what is going to come out. Because you can test it on a small scale, build out confidence, run it broadly and deliver it, and then move on to the next step. So that creativity that the agents have in running these things then becomes very helpful to deliver it as a boring step in the upgrades. So then what does that look like in practice? It is very simple. So I've been telling this for years, but like I said, the audience for this is shifting to agents. So just know that this is underneath there. But what you want to have, ideally, is on the left hand, where you see some YAML lines of code defining some steps that need to happen in a larger migration. So ideally, we expose some building blocks for you already for the common migration steps where someone changed a package declaration or an artifact ID, and now you need to make those kind of changes. And we just provide a building block for you to do those steps. So this is something that we saw, let's say, with the Jackson version 3, where every artifact ID now has a different group ID. Some of them were merged, some of the packages were different. You need to make all of these small, repeatable steps that you can read in a migration guide, but they're very tedious to execute. And if you ask Claude or any other tool to execute those migration steps, it's going to lose focus. It's going to not deliver that repeatably. And it's going to ask you to repeatedly upload every file and solve the same problem each and every time. And then say that you can't do it with the building blocks that we have, then it's when you use a custom recipe, which in this case can be Java, can be C#, Python, JavaScript, TypeScript. I can keep going for a while. But it's always the same pattern. You use the visitor pattern to traverse a tree representation of the code to make the code change that you need to deliver that. And then, like I said, the moment that you have that recipe, you can run it broadly, and you can take it from something that is very tedious to do manually, very complex to get right with automation, to something that just runs in a couple minutes on a couple of hundred, couple thousand repositories to get them all migrated. And then the outcome of a recipe is always deterministic. The same input is always going to give you the exact same output. Did I press? Yes, I think so. So this is what the loop then looks like for us. So typically to author a recipe, we ask you to provide it with like a before example and an after example what you want to happen instead. So typically that will be the old package name, the old methods, things like that. And then the after would be what it looks like after having it migrated in this way. And then from there, the agent will draft a recipe to make it match those conditions. So we have a testing framework that allows you to verify exactly that the input is always going to result in the exact output. It's going to be formatted correctly. It's going to be preserving your style and your comments and all those things. And then from there, we can tighten it further by running that recipe that we've verified with unit tests on a set of projects in the wild. And we always learn something. We always learn about edge cases. We're always very thankful when folks report edge cases that we didn't consider yet. Sometimes we tell you, well, why are you doing it that way? Well, we'll try to make it work anyway. And then from there, we will add those recipes to the catalog of recipes that we have. And that way, what you end up with is a recipe that you can execute, and every time you can run this in parallel, and you shift the complexity of that migration from something that you run with a GPU to something that runs on a CPU. So no more buying tokens at your LLM provider. You're just going to run something just basically as quickly as your compiler would otherwise run it, and end up with a deterministic runtime and no tokens used in that sense. And then what we have seen some customers experiment with is try to skip all of what I've just shown you, ask Claude or Copilot to do all of that work. And then, thankfully, nearly every time it's brought up, we get back from, oh yeah, we tried it that way. It took about 3 days, and it got back with having done maybe a quarter of the work, and then I was out of tokens for that month. And that is not great. And it's not happened just once, it's happened repeatedly. I think 3 weeks ago, we heard from Uber that they've already spent all of their 2026 budgets on tokens, which is not great when it's April, the moment that they came out with that. So if you do find that, it is something that you struggle with, come find me in the hallway. I have some trial licenses for like token providers if you want. Not if you're Uber, that's kind of, I don't have those much trial licenses. So then, with that, let's see then what to do next. So we've, in our case, productized the loop that we saw to develop these recipes, to try and run them first with unit tests, to try them out on larger project sets through skills that we provide our agents with. So these skills are going to try to run through that loop that you saw of discovering first, what am I using, or what is the goal that you set, discover what you have, then from there, author recipes to fill the gaps between what we already have versus what we need next. And then from there, run it and build out confidence, and then run on more and more projects to discover those edge cases. And this way, the skills that we provide, they're just a distillation really of our documentation. It's going to learn which of these styles of recipe development to use, and then typically this way you'll have a bit of like a TDD kind of flow for developing new recipes. And then this is where we hope that you will get involved as well, because we see ourselves as like the shepherds of the OpenRewrite framework and platform for community recipes as well, where if you find that you have, with help of agents, built an automation that didn't exist yet, and you think that others would benefit, definitely reach out. We're always very thankful for folks that produce recipes to contribute back to the community so that the next person coming around will already be able to use that existing recipe. And we will help get them up to shape, we will help improve the quality, we'll help make them available to everyone, such that we can expand the catalog and do more of these migrations in a deterministic way, such that you're not all solving the same problem all of the time for the tedious work that we're hoping to do. So that is my slight call to action. Please help out. It's a large ecosystem, and we'd hope to cover more of it. So then we're going to look at closing the long tail. So this is where a lot of these migrations go to die, because you can run a recipe, it will get you some part of the way, hopefully as far as we can in a deterministic way. But at some point, you end up with something that is genuinely weird. Your colleagues have done something that we hadn't anticipated, we hadn't seen, we hope to never see again, but we're going to try to, as much as we can, automate the tedium through deterministic recipes, but sometimes there's cases we can't cover. So as an example, if you take like a recent Hibernate upgrade, they used to have a method called save or update, which is kind of doing two things at once, which isn't great. And now in a newer version, they're going to have you choose between save or update. And I can't tell from the context, and nor can an agent, nor can a typical developer, which ones of these two you were going for. So what we do in those cases is insert maybe a small comment above. So upgrading to the next version of Hibernate, you'll see a compilation error, but you'll also see a helpful link to the documentation of this is what you should be looking at to judge which of these two you need. And this is then where you get an agent involved, or where the agent starts to read your documentation, read the migration guides for Hibernate, try to figure out, in your case, specifically what you need, because we can't tell from just looking at the code. And then you can help it get more of the way there to finally close that problem. So then, it's also the point where it doesn't make sense anymore to push harder on authoring recipes, because you get diminishing returns. If we're going to help you migrate every web endpoint, where you have thousands of them, that's a clear case for a recipe. If you have maybe one configuration file for the one framework that you're trying to get rid of, maybe that is something you can leave perfectly well to an agent and doesn't make sense to write a recipe for. So then, yeah, hopefully we're going to get you further and further there so that you can stop lying to your manager saying we're nearly done, we're 80% of the way there, and really get you all the way if we can. And then we have a couple different ways which we can speed up that last bit as well. So we're aiming for getting you a fast feedback loop as you get agents involved in this type of work. So you'll be working in pairing with an agent, and we're going to aim to have that agent use a context of your code that is populated specifically for your project. So what we often see is that an agent will start a bit of work on your code, but it is not up to date with what has been done before. Whereas if we make that available to it, like what are you coming from, what have you already ran, what are your higher level goals, then it can better infer the next actions to take. So then with that, what the flow kind of looks like is that we have on the left-hand side, we have that coding agent trying to help you clear that last hurdle of the migration, and it doesn't matter much whether that is Claude or Cursor or Copilot or, God forbid, GitLab Duo. You never quite know what you're forced to work with. But we're going to expose these tools and skills as something that is generic across these different agents to work. Now we expose some of the recipes that we have as MCP tools, such that if you want to find usages of a particular method, then it can be, again, sped up by having a localized index file pointing you to all of the usages of that particular one, such that you can speed up the processes that your agent doesn't, again, have to start scanning all of your project and try to infer where things are used, but try to read it all at once. And then, like I said, we can execute further recipes. We can write them on the fly if there's a small sub-part of a migration that we can do. And then hopefully in this way you get up to speed with a complete migration. So what we did find is that a lot of the time that agents use when working on your project is actually building up an understanding of what your code actually does. So it's You'll know the patterns. I have a small demo that I can run as well, and I'll let that run as we talk. Let me try to switch to that one. Does that pop up? Not yet. Just a moment. Yes. Now I need to find my window again. It's not there. So this is the typical flow that you can kind of expect when you use these type of agents. And I've done a recording here because I never trust the Wi-Fi. But what you can see, and I'll talk you through, is we have two flows here. On the left, we have an e-commerce application where we don't have any specific context populated for this project. Whereas on the right, we have the exact same project, but we have a indexed context for it to work from the moment that you want to ask a certain question of your project. Now in this case, we are going to be asking the same question, both left and right. We're going to compare the difference of having an indexed context for this project to work from as what you would see if you don't have that. And that indexed context looks like this one. It is the result of running a couple of recipes that we expose to you all to run, where you can say, run this on my project, create me these files. It's some indices, and it is the data underpinning those indices to inform it about the coding standards and what is being used throughout the application. Then we're going to ask it a question in both sides, and the question that we're going to ask is something to help develop the next feature on this project. So we, in this case, we say I have a requirement to delete all data associated with a specific order. Which system do I need to work with in order to do that? It is representative of a type of task you would give to an agent. And then on the right, we will be using that pre-built context that we have to use that to inform the work that we do. And this is where you need a bit of patience when working with agents. This is where I tend to spin up a couple in parallel as you do this. But what you will see on the right is that we immediately jump to using those indices And we have we can now skip all that inference that it usually does when trying to build up an understanding of your code. And then now within half a minute, we have an answer of where to look, because we didn't have to grab through the projects, as you can see on the left. We didn't then have to read the files. We didn't have to ask to build up some knowledge of those projects. We can immediately give you an answer on the right-hand side. And this is where, on the left-hand side, we're still trying to do all of that. We're still expensing tokens to build up that understanding of your project, which is going to be the exact same understanding that you need 5 minutes from now for the next task, and the next task that you do after that. And this is, again, why we think that having that context, which is just the output of some recipes that you can wire up yourself as well, is a big improvement for both the time that you need to run queries like this, as well as the tokens that you're going to use to do this type of work. And then I can let it run at the very end for another couple of minutes. It's going to give you pretty much a similar answer, even though on the right it's going to be faithful to the indices that you have. So we've discovered everything that we knew here in a deterministic way. For on the left, it is that inference. It might be different, it might be incomplete, it might be incorrect, and it's going to be definitely slower. What we do if we let it run all the way to the end, and I'm just going to fast forward because I'm an impatient person. I think like at the 4.5 minute mark, I think on the left you can see that it's finally now found some of the same. Then we're going to compare the token usage that we have. So on the right, we can very clearly see that it took us 40 seconds to run. On the left, it took us 3.5 minutes to run this. And then we ask, in this case, Claude, how much tokens did you spend doing this type of work? So in this case, it's very clear cut. This one spent about like 300,000 tokens total. It didn't use any sub-agents because it was just reading a CSV file. It's very clear. Whereas on the left, it had a couple of different sub-agents, 112, and then total, it was using 4 million tokens. So that is, you can probably see both in terms of performance as well as in token usage, you get a very clear, distinctive pattern of usage there. So with that, let's skip the video and wrap up. Come on, I'm clicking on the wrong thing. Come on. Yeah. Okay. And full screen this one again. So that is what we kind of see when you do this the type of like indexed work on a project, is that you're going to spend a lot less time and a lot less tokens, and it is going to speed up any use case that you do, including the type of finishing up that migration that you saw, because you're not having to ask what is the state of my project, you're going to know what you have in the same way. So the concept that we use there is pre-think. We have a couple blogs that explains that further, and it's using recipes that are in the OpenRewrite catalog as well. So we suggest that you try that out, you run it on your projects, because you can very clearly see the savings that you would have if you do so. And a couple more slides on this part. So like I said, this is a small more bit of explanation of what is actually in that context. So you can see on the left, we list the typical things that you need for any kind of work. We're going to look at the dependencies that you have. We're going to look at your database connections, your web endpoints. We're going to look at what else we have, a bit of an architecture diagram. And then we're going to wrap all of that up in a agent.md file, Claude.md file, cursor rules, to tell it this is what the project structure is like. And then if you need anything, use this reference. Don't start grepping, don't start reading files and building up a model, because we have all of that for you. And then we add some additional conventions in there, such that when you produce new code, which for recipes, it can happen, but it's not always a typical case. But when your agent's going to produce new code, we want it to adhere to the conventions that you have. Use the same coding styles that you have. Be aware of gaps in your test coverage when you change something here. You maybe need some additional care to write some tests there. And this then collectively is going to help you, next time you author something, be in the style of what you actually want to use instead. And then we get to what is sometimes the tricky part of these migrations, where we've solved the technical aspects. We've, like I said, identified the waves. We're running them in smaller increments. We're sending out PRs at this point to the teams. And then the tricky thing is you need to convince folks to actually merge them. This is kind of where, if you don't handle this aspect well, it could come across like your mother-in-law giving you well-intentioned advice that you're really trying to find a way to hate that advice and not do it at all. So this is where the social aspect of getting this through becomes important as well. And we've spoken through a couple of companies in the industry on a panel, like what were they finding that would be of hindering or helping getting these changes across. And what they found mostly is that you want to focus on optimize for the folks reviewing your code. And I think that's especially true now with agentic tools writing code, is that your reviewers, they are very easily fatigued. So anything you can automate in that review process, do as much as you can. Anything you can validate before opening up a PR, do as much of that. Because your reviewer is just looking for a reason to decline something and move on to the next thing. And that is like, look for ways to optimize for that one. And then you also want to be sure that your PRs look like they were created by a human. Have a friendly face on that. It can be this face, it can be a different, but have it be something that is not a bot, because I think we've all seen a couple dozen pull requests just from bots that get ignored and not picked up in the same way. So then with that, let's wrap up with some takeaways. I have them all on a single slide, just to make things easy for you. So again, the state that we're after, it is not to modernize. The goal for us is to get you in a clean and consistent state so that you can deliver value. That is really what you're after and what you should focus on when you do any of this work. Now, for the migrations that you have to do, we suggest that you break them up in small waves, in increments that you can deliver in isolation and get immediate value merged already. And then never like do the depth first approach, because that is not a great way to be sure that you have something to show for at the end of the week, the month, or whatever time it takes you. Now, do heavily use these agents to write specific recipes that you need, and they will make sure that you can start to run these migrations at a scale in a deterministic way, and then hopefully in that way deliver that. And in my case, please contribute back those recipes. We'd love to help them. We'd love to get everyone in this room. Only one person needs to figure out the next library to migrate, and then everyone can benefit from there. And also put time ahead of time already in your thoughts on that long tail. How do you actually get the work merged near the end of the day, such that you don't discover at that point that no one was interested in the PRs that you're creating? So with that, I want to thank you all for your attention. Good. And we do have time for questions. So if anyone has a question, we have a mic going around, and then love to hear your thoughts. Front row? Yeah.
Thanks. Very insightful talk, and very opposite to where the industry is going with AI. And I really like it, because I did think that people were forgetting the traditional ways of doing software engineering, and I think what you do here brings that to surface. How would you compare yourself, not yourself, but the tools you're talking about, with the likes of what's already there? And I'll name some of them, and they solve some parts of the problem, like OpenSpec. Tessel has released some nice tools. I don't know if you know of the company called Tessel.
Nope.
So I like your skills, but I'm curious if you got your skills analyzed and optimized using your own ways or using other tools. So a few questions in one question,
no,
so
yeah,
if
sure.
you don't mind.
So if you look at a company like Tessel, what they offer, if I understood correctly, and then please correct me if I misunderstood, is that they offer agents optimized for a particular task, and they can help you part of that way there. But what they sell is non-deterministic. So what we aim for is try to achieve as much as you can in a deterministic way, because you know that part at least you don't have to review. And if you have a couple 100,000 repositories and pull requests, that is really what you optimize for. So do as much as you can in that way, whereas with those agents that they sell, you're not quite sure how they're making the code changes, and you might be solving the same problem repeatedly. Like this one method was renamed. Oh, I need to figure that out on this file and the next file and the next one after that. So I would say try to use deterministic tools, maybe run by agents, and then only review the steps that they are doing non-deterministically. I hope that answers your question.
Yeah, makes sense. Yeah, definitely different tools. Well, what about OpenSpec? Because that does something similar and solves some part of what you already told.
I can't speak to OpenSpec. I've not worked with that myself, so then yeah, I'm very honest there that if I don't know, I'm not going to babble on stage. So.
No worries, we can talk about it.
Yeah, no, definitely do. Any other questions? If not, I am around. So if you see me anywhere, then just grab me, and I'm happy to chat, even if you don't want to admit what Java version you're using right now, and for a big audience. And then, yeah, we'd love to engage. And then with that, enjoy the conference, and hope to see you soon. Good.